How exactly does BGP, the Border Gateway Protocol, choose its routes? In this micronugget, we're going to do a brief overview of how the internet works with BGP and then specifically take a look with an example at how BGP can choose the best routes when it's presented with more than one path. Let's jump in. So to appreciate how BGP makes forwarding decisions and chooses routes, let's make sure we're comfortable with what BGP, the Border Gateway Protocol, does for a living. In our network that we have here, I have 5 clouds. And these 5 clouds represent the entire internet. Now, I know you're thinking, Keith, the internet's a little bigger than this. And I know that's true. But for our example, we'll say it's just these 5. These 5 clouds represent 5 different companies who are providing internet-based services. And they are given something called an autonomous system number. This company has been given autonomous system number 12 for them, and autonomous system number 34 for this company, 56, 910, and 78. So how do we get the ball rolling with IP addresses on the internet? Well, the first thing that happens is we have a need. We have a need for addresses. So there's the IANA, the Internet Assigned Number Authority, that's responsible for managing all of the IPv4 and IPv6 address space. Next, to hand those out, the IANA has hired or worked with another division called the Regional Internet Registries, and there's multiple of them, several of them. If a company wants to go in business or they want more IP addresses, they make a request to their local regional internet registry, they get their IP addresses. So let's say, for example, that this autonomous system, or AS910, what they want to do is they want to request a new block of addresses. So they go to their regional internet registry and they say, can we please have a new block of addresses? Now, maybe this was like a dozen years ago when there were plenty of IPv4 addresses available. Let's say they make a request and they're given this block of addresses, 23.64.0.0. Let's just dream big. Let's say they're given a /12. That means the first 12 bits are the network, and everything after that are available addresses that they can then subnet as much as they want to and rent out to customers. So how does this all fit in with BGP? Well, if this autonomous system number has been given this address space to advertise and to share with the world, the job of BGP is to do exactly that. So once we have those networks installed inside of our autonomous system, our next job is to advertise those routes to neighbors. So we're going to advertise the routes to ASN 56, and we're going to advertise it up to ASN 78. And these autonomous systems will also advertise and propagate those routes all the way across the internet. So what's the problem? Well, here's the challenge. Let's say that autonomous system 12 learns about the network 23.64. So it's learned it, but it's learned it from 2 sources, from here and from here. Which is the best way to go? Should it go path A across here, or should it go path B across here? And this is the point of this micronugget, is to give you the decision point of how does BGP choose the route to get to the 2364 network. Does it go path A or B? And the way it works is this. When ASN 910 advertises the route, it puts on the path 910. There's a little attribute, a little value called what path has this route been advertised on. When AS56 advertises it over, it tacks on its autonomous system number 56. And so when this route shows up on path B, it's going to show up that it went through AS910, it went through AS56, and here's the route. On path A, it's going to appear like this. It's going to have 910 as part of the path, it's going to have 78 as part of the path, and it's going to have 34 as part of the path. So for path A, it's going to look like it went through 910 and 78 and 34. You with me? Those 3 autonomous systems are up top, and these 2 autonomous systems for the path B. So all the router does inside of BGP, I shouldn't say all, but the primary decision making for which path to use is by looking at the length of the path. Because this path up here is 3, and this path down here is 2, it's going to choose the path with the lowest number of autonomous systems in the AS path list. That's it. So let's take a look at this in action. Let's say Autonomous System 910 has been given that network block at 2364/12, and R10 has been chosen to inject or introduce that network statement into BGP. We could go over to R10 to simulate this, go into configuration mode for BGP for Autonomous System 910, and simply add the network statement. And now he has the ability to advertise that network. Now 910, this AS is advertising it northbound to 78 and also to 56. 78's advertising it to 34. And as they advertise that route, they're going to append to the autonomous system path their AS number, their autonomous system number. Why is that important? Let's go take a look at R1 and I'll show you. If we do a show IP BGP right here, it's going to show us that we have one path for that route. And now we have two. So BGP takes a few moments to converge. I'll be quite honest, I was expecting both of them to be there the first time. So this is the network that we're after, the 2364/012, and we have two entries for it. If we take a look at the far right, this far right is saying that the first AS it came through is 910 because we sourced it, and then it went through 56, which is right here. The other route for that same, the other path for that same network was sourced from 910, went through Autonomous System 78 right up here, and then went through Autonomous System 34 right here. And now the question comes into play, how does BGP choose its routes? And the answer is, it's going to choose the route with the lowest path. Now check this out right here. If we take a look at this route right here, or this path, this only had to go through 2 ASs. This one had to go through 3. And that's why, my friends, this little guy right here, the little greater than symbol, means that is the best route. This router is choosing the route that went through the 2 autonomous systems as opposed to the one that went through the 3, all because of the AS path. The lowest is the best, and that, my friends, is how BGP chooses its best path for a route. I hope this has been informative for you, and I'd like to thank you for viewing.